Hey guys, today we're going to learn about finding derivatives of inverse trig functions. So let's just start with the regular sine and cosine graphs. Remember that when we find inverses, we have to restrict domains so that the function becomes one-to-one and monotonic. So let's start with the sine graph. If you look at the red curve, that's our sine graph. And in order to restrict it so that it is one-to-one and monotonic, we can restrict it from negative pi over 2 to pi. To pi over 2. And now this function is one-to-one and monotonic. The inverse will still be a function. If we look at the cosine graph, we'd have to restrict it from 0 up until pi. Now when we restrict those domains, they're going to become the range of the inverse function. So the restriction again on sine would be negative pi over 2 to pi over 2. And the restriction on cosine would be 0 to pi. Once we restrict them, we can talk about their inverses, which look like this. And notice again, the domains become the ranges. That's how the inverses work. You flip x and y. And notice it's the same shape flipped around. If you look back at this visual, and it's restricted, negative pi over 2 to pi over 2. Negative 1 to 1 becomes the x-axis. Same thing with the cosine graph. Now it's restricted from 0 to pi, and the range becomes negative 1 to 1. The domain becomes negative 1 to 1, right? So now we can actually use these, their functions, and we can talk about their derivatives. So let's start with the sine inverse derivative. We'll start by saying, let's let y equal sine inverse of x. If y equals sine inverse x, sine of y is equal to x. Let's create a triangle for this so we can come back and refer to that. So if we were to label the triangle, sine of y is opposite over hypotenuse. So x over 1, the opposite side would be x, the hypotenuse would be 1. And if you were to do Pythagorean theorem here, let's call this missing side s for now. Side squared plus x squared equals 1 squared. Subtract x squared from both sides. We have x squared equals 1 minus x squared. Square root both sides and only consider the positive because we're looking at a side length. So there's your third side of the triangle. Now why is that important? So let's move this to the side. Let's continue by finding the derivative of sine y equals x. That way we can find the derivative of y, our inverse sine function. Okay, so on the left side, we're going to have to use implicit differentiation. The derivative of sine is cosine y dy dx, or let's say y prime, equals derivative of x is 1. Divide both sides by cosine y, and we get y prime equals 1 over cosine y. So now let's use the triangle that we just put together in order to rewrite 1 over cosine y. So looking at our triangle, cosine is adjacent over hypotenuse. Adjacent would be 1 minus x squared over hypotenuse 1. And now 1 divided by 1 minus x squared is just that. And now we know that the derivative of the inverse, y prime, is equal to 1 over 1 minus x squared. Okay. All right, the next two I'd encourage you to try on your own. You don't have to. I'm going to go a little quicker through these than I did with the first one. So x equals tangent of y if y is equal to the tangent inverse of x. So if we took the derivative of both sides, derivative of x is 1. Derivative of tangent y is secant squared y times the derivative of y, y prime. And then that means if you divide both sides by secant squared y, y prime is equal to 1 over secant squared y. Let's set up our triangle for our original x equals tangent of y. Tangents opposite over adjacent, so we have x here, 1 over here. And then if we did Pythagorean theorem, we would get 1 plus x squared on our hypotenuse. And from there, to prove the derivative of the inverse of tangent, or tangent inverse, the derivative of y is 1 over secant squared, which we can also think of as 1 over, sorry, not 1 over, but cosine squared y, which in this case is adjacent over hypotenuse squared, meaning that y prime is just 1 over 1 plus x squared. So now we know that the derivative of tan inverse is just that, 1 over 1 plus x squared. And going back to our sheet, derivative of tangent is 1 over 1 plus u squared du dx, okay? Last one. Y equals secant inverse of x. Okay, here when you set up your triangle, be careful because if we have secant, we're thinking cosine, which is adjacent over hypotenuse but flipped, so hypotenuse over adjacent. So x ends up being our hypotenuse. But if x is our hypotenuse, we want to make sure that it's positive. So we put absolute value bars around that x value. And then if you went around and did the rest of this triangle, you would find that this height right here is just x squared minus 1. So now again, going through the process, in order to find out what y prime is, we'll find the derivative of this equation. Derivative of the left is 1. Derivative of the right is secant x tan x, or secant y tangent y, attach y prime. If we solved for y prime here, we'd get 1 over secant y tangent y. Now, going through this, you guys now know your trig rules. You can apply the triangle. You'll end up with 1 over the absolute value of x times the square root of x squared minus 1 as your y prime. So the derivative of secant inverse is just that. Notice that we're not going to do all the proofs. They're pretty much the same with opposite signs. So if you look at, for example, cosecant is just negative 1 over the absolute value, because you're looking at sine's derivative, which is negative cosine. So think of it that way. Same thing with the cosine inverse. You have a negative 1 on the top. So just pay close attention to that to help you remember them. Once you get these down, you're going to start looking at the sheet a little less. It just becomes way easier after you apply them a million times. Don't worry about the right side yet. You'll watch a video on that part tomorrow. Okay? Now we're going to practice just a couple of these so that we know how to apply them. Alrighty, so first rule we're going to apply is the sine inverse rule. So the first example is y equals sine inverse of 10x. So using that formula, we're going to plug 10x in for u and find the derivative, or attach the derivative of u. So in this case, that ends up being y prime equals 1 over the square root of 1 minus 10x squared, make sure you put that in parentheses, times the derivative of 10x, which is 10. And if we simplify that, that's 1 over 1 minus 100x squared. I'm going to attach the 10. 10 times 1 is 10. Just put it on the numerator. And that's your final answer. Be careful, guys. I should have had a d dx, meaning derivative of the sine inverse, is equal to 1 over 1 minus u squared. So just be careful with that notation. It's not just sine u, it's the derivative of that. Next example, using the tan inverse, we're going to find y prime. And in this case, your u is x to the fourth, so we're going to plug that right in there. And the derivative of u is 4x to the third. So it becomes 1 over 1 plus x to the fourth squared times 4x to the third. And if you simplify that, it's 4x to the third over 1 plus power rule x to the eighth. That's your final answer for y prime. Y equals secant inverse of the square root of x. And for your sake, the rule is, derivative of secant inverse of u equals, don't have much space, 1 over the absolute value of u times the square root of u squared minus 1 du dx. So applying that, we have our square root of x going in here, and you're taking the derivative of that on the edge. So y prime will equal 1 over the square root of x times the square root of x squared minus 1 times, if you take the derivative of x to the 1/2, you get 1 over 2 root x. And now when you simplify that, it's just 1 over 2 root x times root x, x, square root of x squared is just x again, minus 1. And that's your final answer. No need for absolute value here. You have your square root, your x within a square root, so the inside cannot be negative, and there's no need to put an absolute value there, okay? All right, last one. So we have our sine inverse rule, and we're finding the derivative of sine inverse of x over 3. So when we apply this, I'm going to plug my x over 3 into u and find the derivative of x over 3, which again you can think of as just 1/3 x. So that would give us 1 over the square root of 1 minus x over 3 squared times 1/3. If I simplify that a little more, I get 1 over 3 times the square root of 1 minus x squared over 9. Now watch how we clear this fraction inside your radical. We do have a 3 as a coefficient out here, which is also the square root of 9. And we know we can multiply square roots by one another by multiplying the insides. So the square root of 9 times all of that is just distributing the 9 minus x squared. So our final answer becomes y prime equals 1 over 9 minus x squared. Now this is correct. I don't want fractions if you can clear them. And this will really help you when it comes to integrals and recognizing things you can pull out of your radical. So please keep that in mind.